Hello students, welcome back to our maths class. Today we'll continue further this session with the next exercise 6.4 of chapter number 6. Before going to the exercise, let us learn the few topics related to the exercise here. Now we have to learn first two special triangles, children, here. The first one, equilateral triangle. The name itself suggests something to you. Equi means something that is equal, right here. So it is a triangle in which all the three sides and angles are equal. You can see here, children, the triangle given here marked with the angle 60 degree each. That means the given angles of the equilateral triangles are always of the same measure. Also the given sides are of same measure. Suppose this is 5, that means all the three sides will have same measure, that is 5 centimeter, meter, whatever it is. Okay, so this is the defined for equilateral triangle. Next, isosceles triangle. Now, it is a triangle in which two sides are equal and the base angles opposite to the equal sides are also equal. Now let us understand step by step from the first. Two sides in isosceles triangle, children, two sides of the triangle are equal. You can see I have marked here two sides, that is ED and EF are equal. Suppose I take it as 5, 5 just for the sake of understanding, children. So these are the two equal sides of the given triangle EDF or DEF, okay, whatever. Now, next, the base angles opposite to equal side, base angle. You can see base is which, what? DF. DF here is the base of the triangle. Now, two angles opposite to equal side. Suppose the opposite angle of ED is angle F and opposite angle of EF is D, children. That means when in isosceles triangle, if the it has two sides equal, then its opposite base angles are also equal. That means angle D and angle F will have same measure. For example, suppose this is 50, then even this angle will be equal to 50 degree only. Next question. Now the next property related to the triangle here, that is sum of the length of the two sides of the triangle. Now property related to the length of the two sides of the triangle. What it is, let us read. Sum of the length of the two sides of a triangle will always be greater than the third side, whether it is an equilateral, isosceles or scalene triangle. Okay, children, so here this is the next property that we have to understand very nicely here. You can see the given triangle ABC. According to this property, the sum of two sides, that means two sides, you can take any two sides of the given triangle. When you add the measure, two sides, it will always be greater than the third side. You can see here AB plus BC will always be greater than AC. Then AB plus AC, if you take AB and AC, you will take, it will be always greater than BC. Similarly, if you take AC and BC, the sum of these two sides will always be greater than AB. Okay, so that is the property of this triangle here. Now, this is like inequality theorem. The sum of the length of any two sides of the triangle is greater than the length of the third side. So this is very important property which is based on our next exercise, children. Very easy to understand with this figure, right? You can see here a triangle with three different measures given to you, 7, 8 and 9. Now if I use that property that the sum of the measure of this two sides is greater than the third one. You can see here, if I take first 7 plus 8, children, 7 plus 8 will always be greater than 9, right? Here, if I take 8 and 9, when we add these two, obviously it will be the greater than the third side, that is of 7 centimeter, meter, whatever. Similarly, 9 plus 7, if I take 9 plus 7 will always be greater than its third side, that is of 8 meter, centimeter, whatever given to you in the question. This is generally for your basic understanding. So let us see what we can do with the help of this property further. So let us start with the exercise here. Question number 1. Is it possible to have a triangle with the following sides? Children, here it is asked to us, these are the 3 different measures of the triangle. Then according to the property, can this triangle be possible or no? Now let us start. The 3 given measures of a triangle are 2 centimeter, 3 centimeter and 5 centimeter. Now children, as according to the property that the sum of the length of the 2 sides is always greater than the 3rd side, using that property, first let me take 2 plus 3, that is first 2, that will be equal to 5. Okay, so when I get here 5, the 3rd side that is also 5. That means both this are equal, but according to our property it has always to be, that is the 2 sides measures has to be greater than the 3rd. That means here it is not possible to draw a triangle whose sides are 2 centimeter, 3 centimeter and 5 centimeter. That statement you need to put as your answer. Okay, because the sum of any 2 sides of this number is not greater than the 3rd side. Next, 3 centimeter, 6 centimeter and 7 centimeter. Now using that property rules, let us calculate it. Now the first 2 sides, 3 plus 6, 9. That means 2 sides measurement is greater than the 3rd one. Taking another 2, 6 and 7, the total is 13. That means 13 is again greater than the 3rd side, that is 3 centimeter. Remaining 2, again 7 plus 3, that is 10, which is greater than 6, which is the 3rd side given here. That means according to the property, this conditions fits there, right? So thus the sum of any 2 of this number is greater than the 3rd one. Hence, it is possible to draw a triangle whose sides are 3 centimeter, 6 centimeter and 7 centimeter here. So let us go for the next one. Now children, here take any point O in the interior of a triangle PQR and is these 3 questions given to us to answer there. You can see the triangle given here. O is taken in the interior of the triangle PQR, and let us see whether these questions are applicable according to this figure and our properties or no. Now if we take any point O in the interior of triangle PQR and join OR, OP and OQ, okay, that means they are asking to join the center with the vertex. Hence we get 3 triangle OPQ, OQR and ORP as shown in the figure. Now according to the property that we have learned previously in the first slides here, the sum of the length of any 2 sides is always greater than the 3rd side. So we have to answer this question based on this property, children. So let us see whether it fits the condition or no. So accordingly you can see that 3 triangles formed here. So let us see the first question. OP plus OQ. That means OP and OQ. It is given greater than PQ. Is this property okay, children? Yes. Yes, OPQ has the side OP, OQ and PQ. Therefore, according to the question, the property holds here. Next, OQ plus OR is greater than QR. That means OQ and OR. Yes, the measure of 2 sides is greater here, children, you can see, than QR. That means our answer for this question 2 is yes. Third one, OR plus OP greater than RP. OR, OP greater than RP. Children, you can very easily see from this figure that yes, these 2 measures, when you add them, it will obviously be greater than RP. That means for this question, our answer is yes. So let us see what we have next. Now children, here we have a question. AM is a median of a triangle ABC and we are asked the question, is AB plus BC plus CA greater than 2AM? So this question we have to prove, this condition we have to prove considering the sides of a triangle ABM and AMC. Okay. Now we know that the sum of the length of any two sides is always greater than the third side. Okay. Now this is the figure done, children, triangle ABC, where M is our median there, you can see here. Okay. AM is a median, therefore BM and MC are equal to one another. Now let us first consider the triangle ABM as given to hint to us. So in triangle ABM, you can see, children, here you have to compare AM, that is a median, to the remaining two sides AB and BM. So according to that, children, you can see AB plus BM is always greater than AM, because AM is the third side and the remaining two sides are greater. So that will take it as first condition according to the question. So let us see what we have. The next triangle we have to take it now. Now taking the another triangle, that is AMC. Here, children, again we will compare AM with the remaining two sides AC and CM. So according to that, AC plus CM is greater than AM. That is here the condition number 2. Okay, first condition we had done there. Now what we are asked to do? Now first condition and the second condition, children, you have to add both the condition 1 and condition 2, both LHS side and RHS side together. So by adding equation 1 and equation 2, we get here AB plus BM plus AC plus CM greater than AM plus AM. So both the equation are added here according to each side. Now, but according to the figure, children, you can see BM and CM. Here you can see BM and CM. In all, it is nothing but it is BC. So in place of these two, BM and CM, I can write BC also, because BC is equal to BM and CM. Okay, so in the next part, children, I will put this BC in place of BM and CM. Therefore, AB as it is, so in place of this BM and CM, I have written here BC, AC as it is, greater than AM plus AM, we get 2AM. You can see I have written 2AM. Hence, the given expression is true. So we have proved the given expression that was given, that AB plus BC plus AC is greater than 2AM. Question number 4. ABCD is a quadrilateral. You can see the quadrilateral ABCD here. Now the question, is AB plus BC plus CD plus DA greater than AC plus BD? Children, here AC and BD are the diagonals of the quadrilateral ABCD. Now let us solve one by one. Now the sum of the length of any two sides is always greater than the third side that we know. Right. Now considering the triangle ABC. So we will first take triangle ABC. Children, this quadrilateral will take into the 4 different triangles. Okay. So first taking triangle ABC and always compare the diagonal to the remaining two sides. Okay. So diagonal is AC here. So here in triangle ABC, AB plus BC is greater than CA, or you can write AC, one and the same. That is equation number 1. Then now taking another triangle BCD, again as I told you, compare BD the diagonal to the remaining two sides. So BC plus CD is greater than BD or DB. This is your second equation. Now taking the another two triangles. Now we will take the triangle CDA. Again comparing the diagonal to the remaining two side, children, CD plus DA is greater than AC. That is your third condition here. The fourth triangle DAB, comparing the diagonal BD to the remaining two sides, therefore AD or DA plus AB is greater than BD. That is your fourth equation here. Now children, as we did in the previous sum, adding both the sides of the equation, here all the 4 equations we will add according to each side. So adding the equation 1, 2, 3 and 4, we get AB plus BC plus BC plus CD plus CD plus DA plus DA plus AB greater than CA plus DB plus AC plus DB. Now children, in this thing you can see you have 2 DA, 2 CD, 2 BC and 2 AB. Right. So when I add, what I am going to get here, 2 AB plus 2 BC plus 2 CD plus 2 DA. On the another side also children, you can see here also you can see that AC 1, that is CA or AC is one and the same, and DB and DB also repeated twice. So here on this side also you can see 2 CA plus 2 DB. Now taking 2 common out from both the sides children, taking 2 common out, that is you can see 2 is outside the bracket, in the bracket we have AB, BC, CA and DA in the addition, which is greater than 2 CA plus DB. Now children, whenever you have the common number factor outside the bracket on both the side, you can drop them, cutting 2 on both the side. What is left out? AB plus BC plus CA plus DA greater than CA plus DB. So hence the given expression that was given to us in the question we have proved with the help of the property that we have learned. So children, with this we end this session. Hope you understood this prove that sum. Study well and we'll see you in the next lecture. Till then, bye bye.